Welcome to this edition of Dwyer Tech and Specs. In this video, I will cover air velocity and flow measurement with pitot tubes. Dwyer Instruments offers many styles of pitot tubes, which are a commonly used sensor for monitoring air velocity and flow rate in heating, ventilation, and air conditioning. Pitot tubes are based on Bernoulli's equation, which states that an increase in the speed of a fluid occurs simultaneously with an increase in dynamic pressure and a decrease in static pressure. Pitot tubes sense the dynamic pressure of the fluid at a particular point and were invented by French engineer Henri Pitot in the early 18th century. A pitot tube consists of two tubes and one probe that sense both total and static pressure. The flow impacts on one tube that points directly into the fluid flow that senses the total pressure in the ductor pipe. Radial holes perpendicular to the flow sense the static pressure in the ductor pipe. The space between the inner and outer tubes permits transfer of the sensed pressures to the pressure connections on the opposite end of the pitot tube. The pressure connections of the pitot tube are then connected to a differential pressure instrument, such as a manometer or a magnehelic gauge. The pressure reading shown by the instrument is the velocity or dynamic pressure, which is the difference of the total pressure on the high pressure port and the static pressure on the low pressure port. The fluid velocity is directly proportional to the velocity pressure and can be calculated using the formula shown, with V the velocity, D the density of air in the application, and HV the velocity pressure from the measuring device. From velocity, it is then easy to calculate volumetric flow rate, with flow rate Q equal to the velocity multiplied with the cross-sectional area of the ductor pipe. Dwyer also has an air velocity and flow calculator on our website and downloadable as a mobile application for Apple and Android devices. This calculator will take the velocity pressure and calculate velocity, and with cross-sectional area will calculate air volume flow rate. It also offers the ability to make air density corrections for humidity levels. If manual corrections are not desired, Dwyer offers instruments that can read directly in velocity or volume flow rate, such as a gauge like our magnehelic, a transmitter like our MagnaSense 2, or a controller like our DigiHelic 3. Please check back for next week's edition of Dwyer Tech and Specs on how to take traverse readings for accurate airflow measurement with pitot tubes. Dwyer Instruments, right choice, right price, right now.